Section 13.1.27-T. Researchers wanted to determine if the psychological profile of healthy children was different than for children suffering from recurrent abdominal pain, RAP, or recurring headaches. A total of 210 children and adolescents were studied, and their psychological profiles were graded according to a child behavior checklist. Children were stratified in two age groups, 4 to 11 years and 12 to 18 years. The results of the study are summarized in the accompanying table. We're going to complete parts below. So we have our sample size of each group, which is 70. Here's our sample mean of each group and our sample variance of each group. So we want to compute the sample standard deviations for each group. To compute the sample standard deviation, we're going to use the formula shown below, where S squared is the sample variance. So here is our formula. So S is going to equal the square root of the variance. So if we take a look at the first one, the sample standard deviation for the control group, okay, is we're going to take the sample variance, take the square root of 21.5, and we get 4.6. Okay, next, we want to find the sample standard deviation for the abdominal pain, which is the recurrent abdominal pain. And we're going to take the square root of that variance, which is 12.9, which gives us 3.6. Okay, and then we want to find the sample standard deviation for the recurring headaches, and that variance is 8.7, so the square root of 8.7 is going to give us 2.9. So therefore, there are our standard deviations. Okay, now, what sampling method was used for each treatment group and why? Well, remember that a sample of size n from a population of size capital N is obtained through a simple random sampling if every possible sample of size n has an equally like chance of occurring. The sample is then called a simple random sample. A stratified sample is obtained by separating the population into non-overlapping groups called strata, and then obtaining a simple random sample from each stratum. The individuals within each stratum should be homogeneous or similar in some way. A systematic sample is obtained by selecting every kth individual from the population. The first individual selected corresponds to a random number between 1 and k. A cluster sample is obtained by selecting all individuals within a randomly selected collection or group of individuals. Stratified sampling was used because the researchers wanted to be sure that both children and adolescents were represented in the samples. Okay, now what we're going to do is we're going to use a two-sample t-test for independent samples to determine if there is a significant difference in mean behavior scores between the control group and the RAP group. And we're going to assume that both samples are simple random samples using the significance level of 0.05. So the null and the alternative hypothesis are the following. We're going to have the null, which is the mean of the control group, which is equal to the mean of the RAP group. And then the alternative is then the non-equals between those two. Okay, so now what we want to do is we want to go to the sample T. So we're going to go to our stat crunch, okay, and then we're going to go to stat, and then we're going to go to the two sample T, but we have summary, so we're going to select summary. So we're going to come back up here, okay, and then we're going to put in the information that we need. Well, the sample mean for the control group is 11.6, okay. The sample standard deviation of the control group, which we got here, which is 4.6, and we know that the sample size is going to be 70. Okay, the sample mean for RAP was 9.4, okay, and then the sample standard deviation we got was 3.6, so we got 3.6, and the sample size again is 70 there, okay? And then we know that the null is equal to 0, and the alternative is not equal to 0. And so we're going to select compute, and then this is our information that we're going to get. So if we come down here, okay, we're going to see this particular summary. So here is our information, right? This is how we put it in for the sample T summary. and here is our summary that we want to have. So we're going to take this information from the hypothesis test results. Okay, now we want to find the test statistic for this data set and then rounding it to 3 decimal places. So here is our test statistic, okay, and then we end up getting 3.15. So we round that to 2 decimal places. Okay, so I'm going to change that, put that down for 2 decimal places. Okay, and now what we want to do is we want to find the p-value and round it to 4 decimal places, but we only have 3 decimal places for that. So if we take a look at the p-value here, we end up getting 0.002. Okay, so now what we're going to do is want to compare the p-value versus alpha. So we know that our p-value is 0.002. Okay, and we know back from up here, we're testing it at an alpha of 0.05. And so we know that that number is going to be less than 0.05. So what does that tell us? Well, that tells us the following. That says that if the p-value is less than the alpha level of significance, we're going to reject the null. Otherwise, do not reject the null. In this case, the null hypothesis is rejected, so there's sufficient evidence to support the alternative hypothesis. So there is enough evidence to indicate that the mean behavior scores are different for the 2 groups. Next, part D, it says, is it necessary to check the normality assumption to answer part C? Well, according to the law of large numbers, as the number of repetitions of a probability experiment increases, the probability with which a certain outcome is observed gets closer to the probability of the outcome. Since these are large samples, meaning greater than or equal to 30, it can be assumed that the distributions of the sample means are approximately normal. Thus, it is not necessary to check the normality assumption to answer part C. Okay, next, it says, use the one-way Anova procedure with an alpha equals 0.05 to determine if the mean behavior scores are different for the 3 treatment groups. So here are our null. The null is that the mean of the control group, the mean of the recurring, in this case, we said that the recurring, the RAP group, and the mean of the headaches, the recurrent headaches group. The alternative is that at least one of the means is different. Now, we want to calculate the F statistic. We're going to first calculate the sample mean of the combined data set, and then compute the sum of the squares due to treatment, SST, and the sum of the squares due to the error, SSE. And next, we're going to divide each sum of the squares by its corresponding degrees of freedom, k-1 and n-k respectively, to obtain the mean squares, MST and MSE. So I'm going to go ahead and then copy what we have from up there so we know our information for what is n, which is our sample sizes, and our sample mean. So to compute the sample mean of the combined data set, we're going to round into 2 decimal places. So here's our formula. Okay, we're going to take the value of the sample size, okay, for each one, and for each sample size, okay, we know that it's 70. So each sample size is 70, and even in the denominator, we know that each one of those is going to be 70. Okay, and then we're going to look at the sample mean. So the sample mean for the first one is 11.6. The sample mean of the next one is 9.4, and the sample mean for the next one is 12.8. So in our formula, we're taking the sample size times the sample mean of 1 plus the sample size times the sample mean of 2 plus the sample size times the sample mean of 3, and then dividing it by 70 plus 70 plus 70. So when we do that calculation, we end up getting this the sample mean of the combined data set, of the entire data set, to be 11.27. Okay, now what we're going to do, we're going to compute the SST, rounding to 2 decimal places. So this formula tells us that we need to take the sample size. Okay, so we know what our sample size is. So our sample size is the following, which is N1, N2, and N3. Okay, and then we have our sample means for each one. Okay, and then what we did is we found our combined sample mean. So our combined sample mean is going to be the following, which we got 11.27. So therefore, using our formula, the sample size times the sample mean of 1, 11.6 minus 11.27 squared. So here we can see what our values are. So there is our sample size. And then we have our sample mean for each data set. And then we're subtracting the combined sample mean of 11.27. Now for each individual one, we're taking 70 times 11.6 minus 11.27 squared, plus 70 times 9.4 minus 11.27 squared, plus 70 times 12.8 minus 11.27 squared. So when we calculate that value, we end up getting for SST 416.27. Okay, now what we want to do is we want to compute the MST with the degrees of freedom being k minus 1 and then rounding it to 3 decimal places. Okay, now MST is taking SST and then dividing it by k minus 1. So in order to find MST, we know that the total here for SST is 416.27. And then we know that we have 3 groups. So k is equal to 3 and we're subtracting 1. So therefore 416.27 divided by 2 is going to give us 208.135 for MST. Next, we want to compute the SSE, rounding it to 2 decimal places. So SSE is taking the sample size minus 1 times the variance of each particular sample. So recall our sample variance for each one. So here we're going to take our sample size. Okay, so remember that our sample size is N1, which is 70. There's N2, 70, and there's N3, that's 70. And then we're subtracting 1. And then we're going to take our sample variance. So our sample variance for the control group is 21.5. Sample variance for the second group, the REP group, is 12.9. And then the sample variance for the third group for headache is 8.7. So now plugging this into the formula and doing the order of operations is going to give us 2,973.90. Okay, so now we can compute the MSE with degrees of freedom being n minus k and rounding it to 3 decimal places. So MSE is equal to SSE, which we found here in the previous step to be 2,973.90. Okay, and then we're going to take the value of n. Well, n is the total sample size of all 3. So that means that if we take 70 plus 70 plus 70, that's going to give us the total for n. And so we can see here that that gives us 210, and then we're going to subtract 3 because k represents 3. So we're going to take 2,973.90 and divide it by 207, and we get the value of 14.367. Okay, now that we determined MSE, now we can compute the F statistic and rounding it to 3 decimal places. So F Test Statistic is equal to MST, which is 208.135, and we're dividing it by MSE, which is 14.367. So if we take 208.135 and then divide it by 14.367, then we get the F Test Statistic of 14.487. Okay, now the test statistic for this data, rounding to 3 decimal places, is 14.487, which is what we found here. Okay, now we want to find the p-value rounded to 4 decimal places. Now, because there isn't a particular chart for an Anova when you have 3 different type of data that you need to look at, what you can do is, since you're using the F Test Statistic, you can use the F calculator using 2 of the degrees of freedom. So what we're going to do is we're going to go to StatCrunch. We're going to go to Stat and then select, calculators, and then go to F. And so what we're going to do is we're going to use the numerator degrees of freedom. Since they're both the same, we're going to have 69 here and then 69 here because 70 minus 1 is going to give us 69. And then what we're going to do is we're going to take a look at the greater than of that F test statistic, which is 14.487. When we compute, we're going to get 0. Okay, now recall the reason why we say greater than, because we want to find the area to the right when we're dealing with the F statistic, and we get 0 for the p-value. Okay, now in these examples, you're going to end up getting the same for this particular section. You have the same sample size, so that's what you're going to be looking at. So therefore, the p-value is going to equal 0.0000. Now we want to compare the p-value to the significance level, so we can see that 0.000 is going to be less than the significance level. And so again, now if we know that the p-value is less than the alpha level of significance, we're going to reject the null. Otherwise, do not reject the null, so we know that we're going to reject the null. So coming down here at the bottom, we can see that since the p-value is less than alpha, there is sufficient evidence to support the alternative hypothesis. Okay? So, therefore, there is enough evidence to indicate that at least one of the mean behavior scores is different. Okay, now based on the results from part C and E, can you determine if there is a significant difference between the mean scores of the RAP group and the headache group? Well, note that the result from part E indicates that at least one mean is different, and the result from part C indicates the mean scores for the control group and RAP group are different. The result from part E only indicates that at least one mean is different, and it does not indicate which pairs are different, nor even how many. The result from part C indicates the mean behavior scores for the control group and the RAP group are different, but additional pairs could also be significantly different. Therefore, it cannot be determined if there is a significant difference between the mean behavior scores of the RAP group and the headache group.